Hi, in my last video I showed a small piece of basic code that generates large number of patterns on the screen, but I didn't go through the code and I didn't explain how that code actually works. So in this video what we're going to do is go through this code and explain it in details and discover the magic behind this beautiful and elegant one-liner basic code. So let's begin. Okay, so this is our piece of code that we use to generate large number of different patterns on the screen. So if I run this, it's a simple one-liner. So if I run this, now let's see what will happen. So far, nothing special. We have some patterns on the screen, and now we are beginning to change a little bit. Now we are back to normal. Well, normal like it was at the beginning. But let's see what will happen if we keep this program running for a while. Okay, now we can see that we are changing patterns suddenly. Use different PETSCI characters. Okay, now we are changing color as well. What else will happen here? Okay, so far everything that we seen before, but let's see. Okay, now we are changing. So you see, generating these patterns, it is kind of random, but it's also predictable. But now we have a little bit different pattern, and here we go. So now we are changing color and PETSCI characters. So let's see what will happen now. Now it's going crazy. Yeah, back to no, it's still new stuff coming up. Okay, now you get the point. So this could go on and on for hours. Let's see what's happening here. So it's a very small little program with only one line of code, but the main thing here, the main loop, is our for loop here. Then we have some random generator, and then we simply print out the PETSCI character on the screen. And once our for loop is done, we have a goto command that simply start this process over and over again. So yeah, very simple. So let me start with this for loop because it's most interesting part of this code. So I will write this in a little bit different way. I will break it down in several lines so that we can see what's happening here, and it should be easier to understand. So yeah, let's start with that. Okay, so what we have here is almost the same code as before, just broken in several lines, but instead of printing PETSCI character, here we're going to print that value of variable a that we use in our for loop, just to see what are these numbers that we are generating. And of course, instead of this random step that we use here in form of this variable b, I'm going to remove this, and for now I'm going to just say that this is that b it has value of 1, and here we will just rewrite this. So okay, so for now our variable b, so the step is always the same, it's always the 1. And we are starting with where variable a is not defined, or better say 0. And the first thing that is a bit weird here is that we are using the same variable as start value and end value in our for loop, and also as the main counter variable here. So yeah, let's see how this actually behaves. Oh wow, okay, we need to do a few more things just to break this up. So what I'm going to do is I will set this as line 0. Then at line 1 I'm going to print, we need to know the value of our variable a before the for loop and when the for loop is done. So it's quite important. So this is the start and it's variable a, and then when the for loop is done, so let me move this to line number 6, and line number 5 will be end. Okay, now let's see how our program looks like. So okay, before the for loop begins, we are going to print out the variable a. Then when the for loop is done, also we are going to print our variable a. Go to 1, do we need to change this? No, for now it's okay to go here. What I'm going to do is just to change this one more time to line 7, and on line 6 I'm going to print out just a little bit to divide the cycles. Okay, so let's run this. Okay, so when we are starting, our variable a has value of 0. Now our for loop creates 2 prints on the screen, so prints out variable a as when it's 1, then when it's 2, and then when we get out of this for loop, a variable a has value of 3. So what's going on here? So let me explain you how this for loop actually works and why do we have those numbers. So if we let me clear this. Let me clear this, and what I want to do is list, I believe it was line 3, no, line 2. Okay, line 2 is the one that we need. So we are starting when our variable a has value of 0. So this first parameter, so the start value, should be 1 minus a, or 1 minus 0, and that should give us 1. Now our end value should be a plus 1 or 0 plus 1, which should give us also the value of 1. But it's not the case, because at this point a variable a has value of 1, not 0. So it's 1 plus 1, and that will give us 2. So start value and end value are calculated in different time. Also our step b is 1, and we are seeing here that we're starting with variable a has value of 1, which is fine. We can see that here. Okay, and now we are iterating from 1 to 2. So okay, 1 plus step b, which is 1, will give us of course 2. That's fine, that prints out on the screen. and then the for loop ends. But when we print out the variable a, it doesn't have the value of 2, it has the value of 3. Now, why is that? Well, simply the basic interpreter tried to add one more step to our variable a when at this point when variable a had a value of 2. So 2 plus 1 is 3, which is bigger than this end value here. So then a decision was made to stop the for loop. So the for loop ends, that new value is never printed out on the screen, but our variable a has left with that last calculation, so it has a value of 3. We have 1, we have 2, so we have 2 cycles, but our variable a ends up with value of 3. So yeah, that's the first thing that we have to know about the for loops. Okay, let's now list our program one more time. So what will happen, because the BASIC works with floating point numbers, although I'm writing the integers, when the calculations are done, these are all floating point numbers. So all these values that are part of the code, like for instance this variable b equals 1, in the background gets transferred to floating point numbers. All the calculation is done, and once the result is printed out on the screen, what's happening is they try to round that up. So we are rounding the value, and in most cases, if we are dealing with whole numbers, the result will be rounded nicely back to our integer, so to the round number. But what if our step is not the whole number, right? So what if our step is like 1.05923 or something like that? This is all just fine for our little BASIC here, because yeah, these are all floating point numbers. It will work just fine. But you can see now that our results are a little bit different. What will happen instead of just fixed value here, we choose some random number. Okay, so if we do this, and we need to print out the variable b just to see. Okay, we will see what number we will get. So you can see our step is now 0.156250119. And now you can already see that we are going from 0, starting from variable when variable a is 0, and we end up with 2.050937 and so on. And this is the value when in next cycle, in next loop, we are starting with this value. What will happen if we change this random number, our steps, every cycle? Not just once, but every time. So here, instead of jumping to line number 1, we're going to jump to line number 0. So every time we're going to choose another random number for our steps. Now, let's start to run that. Let me slow this down a little bit. So we are minus 2.65, 5.4, minus 3.3, minus 3.355, up to 5.4. Now we are starting at 5.4 all the way to the minus 3.3, and from minus 3.3 to 5.7, then 5.7 to minus 3.5. As you can see, we are constantly drifting. It simple reason because the floating point numbers have so many digits, and every time that we receive our result, it's rounded a little bit. Well, not a little bit, it's rounded. And when you're rounding a number, you're introducing certain error in your calculations, and this is exactly what's happening here. So you can see we started little by little, we start to drift more and more, and this is what's happening when we print out our PETSCII characters on the screen. The different patterns are generated because of this drifting. And of course this is very slow because we are printing all the values on the screen. When you print out just single character, it's much faster, so the drifts happens much faster. Now the reason why I choose in my code instead of just random here, I've added plus 0.1. The reason is simple, because sometimes this random number can be so close to 0 that our for loop will almost never end, or it will take a long time to end. So for that reason I just add plus 0.1. Now we know that our step will have at least a value of 0.1 something, whatever this random part is. So the other part of our magic happens because of the PETSCII character table. So let's change this code once more, and instead of just printing variable a, let's print character with variable a. But of course our variable a has very low values, so we're talking about from -10 to +10, -20, +20, and so on. We're going to add here plus 174. Now this value of 174 is not just random number, of course. I choose this number specifically. I will show you in the PETSCII character table why. And instead of just printing line by line, we will print character without breaking the line. Of course, we will have to disable this start and end. Let's ram those. Okay, one more space. We need to ram this as well, and then this one as well. Let's list this code one more time. Okay, if we now run this code, we should get the same thing that we had with that single line code. So let me show you the PETSCII character table and what characters do we have around this position here, around this value 174. So let me do that. Okay, so these are our PETSCII characters. So if you take a quick look, you can see that our value of 174 is right here, and this is the character that will display on the screen. If you compare it to the first time when we run the code, it starts with these little characters right here, right, something along these lines. And then as we drift slowly, we begin to use these characters as well, and also these here, including the space. Also, we are using all of these values eventually when we start to drift in that direction. But also, once we are drift below 160, the characters that are here between 159 and 144 are actually control characters. So we can change with this character. We are changing color to cyan, yellow. We're moving cursor to the left, and so on. There are different type of controlling characters. So this is why those changing color happens, and all of the different patterns that appear on the screen. So yeah, that's part of the magic as well. And of course, this when this variable a is not only drifting back and forth, it's also expanding. So once it begins to drift, it actually expands. So the range between the start value and end value is getting larger and larger, and then smaller and smaller, and larger and smaller, and so on and so on. And again, everything depends on this value of b, value of steps that we are going to have between the specific range. So yeah, that's all actually. Of course, now you can play with this. This doesn't have to be 0.1. This could be also 1.9. It would also work now if we run this. You'll see now we have completely different behavior. Of course, we're using the same characters, BASIC characters, but the patterns are now completely different. And also, it will begin to drift eventually. We just need to give it enough time. And here we go. We already went to control characters, and then we completely changed the pattern. Yeah, quite interesting. And as I mentioned before, this could go on and on for hours. But also I want to show you a couple more variations of this similar approach to generate different patterns. So let's try to run this example right here. Now let me just list it to see. So again, we have random steps, but also now we have some pokes and system calls on our screen. Yeah, let's see what will happen now. Oh, look at that. Again, we are drifting. Okay. Oh, we have yellow color. Nice. Now, let's see another example. Take a look at this. This typewriter. Oh, wow. Yeah, a little bit correction, right? And drifts again nicely. I have another example. These are the numbers. Lots of numbers. One more before I leave you. Yeah, we can do, but we don't have to. It's still a single line code. How should I name this one? A pi generator. This is a pi generator, like number pi. Now, we need to be patient, of course. Just a little bit more. And here we go. We start generating pies. lots of pies. So yeah, and now this continues to go on and on and on. Whole bunch of pies. Yeah. Okay, so this was all that I have for you today. So until next time, goodbye.